My name is Kilpatrick. I was formerly of the Sydney office and now I am of the Mountain View office as of 2 months ago or so. I'm going to be talking about the Houdini task force and basically giving you just a broad overview of all of the specs that Houdini is working on and what they entail. So firstly, Houdini is about explaining the rendering engine. At the moment, we've got just a whole bunch of magic. Effectively, what happens in the developers. Keep going. Effectively, what we've got for developers is a bunch of style rules at the start. Things like inline style, style sheets, things like that. A little bit of magic happens. Developers can pull out the computed style or like the widths and the heights of elements and things like this. Lots of magic happens, and then we get pixels on the screen. Hooray! But really, this isn't how rendering engines really work. There's a bunch of these phases that happen in this huge pipeline. So I've got style resolution, box generation, layout, paint, compositing as well. And the developer doesn't really have any insight into what goes on at each of these levels. So Houdini is really trying to provide developers hooks for each of these stages of this pipeline to play with, to implement their own layout, implement their own paint effects, things like this. Currently, it's very, very difficult for developers to do this today. So a little bit of the motivation behind Houdini. From the web author's perspective, it takes donkey's years for things to get implemented in just to get spec'd and then actually implemented across all of the browsers and being useful. So take, for example, Flexbox, which first was proposed 2009, 2010, something like that. Went through 2 major revisions, and probably only now, 5 or 6 years later, does it have enough cross-platform support that developers can actually safely use it, and they'll get a wide amount of the web platform supporting it. From the spec author's point of view, one thing that we hear in the CSS working group is like there's just too many ideas coming out that people want to be able to support. So things like new types of borders, new types of layout modes that people want. And it's really, really difficult to tell which of these ideas are useful and which ones should actually have spec work put into them. So basically what we would like is for people to experiment on the web platform, create, say, a new layout mode, if that's very, very popular, then being able to actually spec that and bake it into the web platform. And finally, from browser vendors, there's just so many new features coming out of the CSS working group at the moment. New paint effects, new layout modes, how they interact, compat issues. And really, we want to provide the ability for web authors to be able to hook in and implement their own features. And so finally, for users, new ideas on the web platform, especially in rendering, costs users performance. So things like Flexbox or grid polyfills, these are done basically by triggering force synchronous layout continuously and with absolute positioning. And these can potentially cause like 300 milliseconds just grid layout just for one element of like children of like 10 or 12 things. Things also like new paint effects as well. Material design ripples is an interesting example of this, where for Polymer they add and remove divs basically once per click. This causes a layout cost. Need to transform, rotate that thing. When really all that we'd like to do is just be able to paint into an element. So really what happens is you've got this sort of performance cliff. If you've got a particular type of border that you want to implement, use the CSS border command. As soon as you want something different, like a border with gradients, for example, you suddenly fall off a cliff. You suddenly go into very, very unperformant land. And what we really want to create here is sort of performance foothills. So you've still got the stuff that's baked into the platform. That's very, very fast. But as soon as you start wanting just a little bit of like gradient borders or like a new layout mode, you don't have this performance cliff that people have today. You sort of just slowly degrade into poor performance. And that's tangible to developers. So the first sort of entry point into the rendering pipeline is style. And so being able to sort of explain the rendering engine, we need to be able to define our own custom properties. So currently what you see on the top here today, this just got checked in last week. Yes. Hooray, Levi! Round of applause for Levi. Woo! And this is great. So you can do things like defining your own scale property, which then just plumps into transform. So on a particular element, you can just go double dash my scale 5, and then that will get scaled appropriately. What this doesn't have today is type checking, or just being able to animate that properly. Try and animate double dash my scale. It's effectively a string. It really doesn't know what to do. So in something called the Properties and Values API in Houdini, we want to be able to allow developers to be able to register properties and be able to define, most importantly, their type. So what the type gives you is, it's going to be initially just number, length, color, a few other inbuilt properties that we know how to parse and know how to animate. And this will allow custom properties to be animatable over, so say that we've got, say, my scale from 0 to 1. We feed this in with a web animation or a CSS transition. This will mean that this will just smoothly animate without any need for the developer to trigger off RAF or anything like that. Currently, custom properties inherit by default, so they go all the way down the tree. We'll be able to stop that and just have it locally applied to one element. And we'll also be able to define an initial value. So if my scale wasn't here, this will be a little bit of an issue at the moment. We can just say that this is by default 1, this will apply as 1. So this is really bringing custom properties to the next level and allowing them to be basically first-class citizens in the style engine. Another key part of Houdini is being able to have a typed CSS object model. So at the moment, we basically, for CSS, just have strings to play with, and that's it. So when you get computed style of an object or write style, you're playing with strings. This means that you have to know how to parse them and build them up. This is bad because when a new, say, color mode gets added, so recently the CSS working group resolved to have a new color mode, which is hex RGBA. So instead of just the 6-digit hex number, we now have 8 digits. All of the libraries that sort of rely on the fact that hex is only going to be 6 digits may break. It's also very, very expensive to deal with these strings. So as you can see, this one's fairly, it's not nice, but it's readable. You're just building up a string appendage. This one here is code that I stole from Google 3. Basically what this is doing is detecting if a browser is in high contrast mode or not. So what this is doing is parsing two string values of the color representation, trying to work out if they're the same or not. And this turns out to be relatively expensive. What a CSS object model will give you is first-class objects. So you can see here, this isn't a string anymore. This is actually a JavaScript object called color value. We'll have things for length as well, length value, number, etc. You'll be able to set these directly on elements like this, and then also get them out as proper first-class objects as well. And then instead of this horrible parsing thing, just go, are they equal or not? Hooray! Levi's excited. So now I'm going to talk a little bit about the infrastructure needed for Houdini. So the really scary thing for browser vendors about exposing hooks, especially from like box generation down, is the fact that this can, this is getting into synchronous code in the middle of the engine, and this is kind of scary. So for example, if you're implementing a custom layout mode on the main thread JavaScript, and in that custom layout, for example, you just removed half of the DOM tree, for example, this would leave our engine in a very, very inconsistent state. What do? We don't want to be able to also get into potentially cycle loops and things like this. So we need sort of a restricted JavaScript world and being able to play with only the things that we give it. The second thing is that browser engines are becoming more and more threaded, if that makes sense. So things like Servo want the ability to be able to do paint callbacks on multiple different threads as well as layout. So we need a piece of infrastructure that allows for us to have multiple instances of these things. So we have the most adorable API name on the web yet called worklets. And what these are is it allows you to load JavaScript into global scopes, and there may be multiple backing global scopes for these objects. So imagine on the main thread, you've just got window.paintWorker. You can import scripts into that paint worklet, but then this might, as a backing implementation, just have 4 of them, all on separate threads, doing your paint callbacks. So again, there may be multiple per threads, and they may be also across different threads. These workload global scopes also don't have any of the APIs that you traditionally see on workers. So things like they don't have post message, they don't have any of the DOM window timer APIs. So things like set interval, set timeout. These are really designed for entering, doing some computation, exiting. They're really not designed for setting timeout and doing event loop processing or anything like that. Talk to me later if you want a more in-depth description of these things. So the first sort of hook that I'm going to talk about is the apply hook. Currently today in the engine, when you define a new CSS property, we basically insert it into a giant function, which basically says, apply this CSS property here. What this apply hook gives you is a hook at the very, very end of this step going, okay, sorry, composing words. Basically what this gives you is a hook at the end, which basically says, I'm going to depend on all of these properties. I'm going to write to all of these properties. This is useful for things like when you want to coerce a child's display type. So I'm going to depend on my parents' display type, and I'm going to write out to my own display type and things like that. It also allows you to do things like shorthands and things like this. So this will happen at the end of style resolution. You basically get this one-shot fix-up step. If you write to an output property twice, it'll probably throw a runtime error at the moment. This is in the properties and values spec as well. Then we get into sort of the layout hooks. Of the Houdini APIs, these are probably the most undefined APIs so far. They're really not much more than documents out there at the moment. And currently we're thinking that there's probably going to be 2 different layout APIs. There's one going to be for block layout, so things for doing like grid layout or flexbox, and there's also going to be one for doing line layout and stuff. So the block layout API will broadly give you 3 callbacks to play with. You'll be able to query the min content of your layout, the max content, and then actually perform your layout. So in layout, you'll be given a bunch of constraints, like what is my current available width? Be able to apply constraints to your children, like my first child's available width is going to be half of what mine is, and then be able to read back their width and height. And then from layout, you're going to be able to return your width and height that you've laid out to. This is going to have some pretty severe restrictions on it. Basically, it's all the restrictions that Grid and Flexbox implement today. So things like it's forced into a containing block, all of your children are coerced into a particular display type, and things like that. But this should allow for pretty powerful block-style layouts to be defined. So a fairly basic Flexbox Grid, sort of a first-level constraint-based layout should all be able to be implemented on top of this API. The next layout API that we're looking at, again, this is very, very undefined at the moment. It's just a few documents at the moment, is being able to define a line layout API. So for example, if you want to define your own layout for Ruby text, again, you'll get a callback for the min-max content. And then in layout, you'll be able to measure text and then place individual line boxes. Again, very, very underspecified at the moment, not much more than a few documents. talk to myself, Shane, or Emil about this API if you want. Tomorrow. We're doing a session tomorrow. Yeah? Yeah. Yeah. Finally, we get to Paint. Paint's probably the most spec'd of all of the hook-based APIs, in that basically what you'll get is a hook into being able to be a CSS image. So things like background image, content, border image, all accept this CSS image type. We're going to define a new function called paint, which accepts a string fancy border. And basically, instead of just being an URL or a gradient or something like that, you'll get a paint callback. This is very, very similar to the WebKit Canvas API, but instead of happening on the main thread and not part, it doesn't happen after layout effectively, it just happens at some arbitrary time. This paint callback gets explicitly called after layout, so you know the exact width and height of the fragment that you're painting into. Another thing with Register Paint and all of these API hooks as well is that it's not defined how long you can be invalid for. You can potentially be invalid for forever. So what this means effectively is that if you've got a very, very long list, for example, and we choose not to paint the elements at the end of the list, that's completely fine to do. That's just a performance optimization that the engine can opt into. So we only really call these two callbacks when the engine absolutely needs it, which is a great performance win. So for Register Paint, you get two callbacks. I'll start with the second one, because that one actually should be first. The first one is called Overflow. And this is used for doing paint-like effects like box shadow, for example. So box shadow explicitly paints outside of the size of your fragment or element. Overflow will basically will return basically how much additional pixels you want on your canvas to the upper, lower, left, and right, and you'll be able to paint into those pixels at the paint callback time. Then you have the paint callback. This gets given a very strict subset of the Canvas Rendering Context 2D API. So explicitly, it'll have stripped out all of the accessibility APIs, things like scroll into view, all the hidden region stuff. You literally can just issue paint commands to it. You get given the geometry of the fragment that you're painting into. So this is just your laid out width and height. The nice thing about this is that when the width and height of your element changes, your paint callback immediately becomes invalid, and if it's on the screen, will be painted next frame, or that current frame that's been invalid. And then you get the style map. So basically, all of the CSS properties that you depend on. The CSS properties, and again, similar to the geometry changing, anytime that one of these input properties changes to paint, will invalidate paint, and you'll only get called back potentially when, say, fancy border changes, for example. Again, this allows us to hold on to the output of paint as you're scrolling down the list or as you're changing something else on the page. It's a nice performance optimization. Any questions so far? Yes?
Do you have to specify the order of the paint here, or does the order of the paint matter? For example, if I have two custom painters, does it matter which one gets called first? Or
no. So there's a few things I missed. I didn't talk about in isolated workers. Basically, it's completely undefined what order the paint callbacks get called in, or which paint callbacks get called in if they're valid, for example. So an engine might just choose to paint all of its valid callbacks. But this also leads to the obvious thing. Well, if Firefox, for example, paints callbacks in order A then B, and when we call them in B then A, then that's going to lead to huge compat issues. The current thinking of the way to get around that is with the worklets. For, say, thread 2 is the main thread, we're always going to have at least 2 global scopes, and then we're going to randomly assign a particular paint callback to a worker global scope. So this means that the developer can't assume that B is going to get called before A, and vice versa. Yeah, Alex. Yep. 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 That paint order, basically because this is defined as a CSS image type, it's just where that CSS image would appear in that giant appendix. So if it's defined as a border image, it will get painted in the border stack and context display thing. Does that make sense? Yep, down here. So it can be used, yeah, sorry. Yeah, so this is valid wherever image is valid in CSS. Cool. Yep.
Do you allow the pixel rewrite API?
Probably not at this stage.
Please say no.
All right, yeah, so no. Yeah, so the question was, are we going to allow pixel readback and writes? The current thinking on this is no, that we're just going to basically provide the write APIs only to the canvas rendering context. This allows us just to build a display list, and that's it. We won't have to do an intermediate raster if you do perform a pixel readback. Justin?
Can you briefly explain what overflow is?
Yeah, so overflow is basically, so for effects like box shadow, for example, how you're explicitly painting outside of the bounds of your element, it's for those type of effects. So overflow will give you, you'll return on overflow basically full values, how much additional pixels you want at the top, bottom, left, and right, and that will get added to your canvas rendering context 2D.
So you're adding
Yep.
to the pixel buffer.
Yep, exactly, yep. And this will also, but the context will be still centered, the logical top of the element will still be the logical top of the canvas. So you'll just write into negative pixel space, if that makes sense. Yep. Yep. Yeah, so how this works basically is that you're not, the input properties and output properties, what you get and what you're writing to aren't the same thing. So basically you can think of, you've got the input properties here, you all read from them, and then you potentially write to output properties. So it you can't build up a loop there. You can get the instance where you're writing to the same output property, and that will be a runtime error. If that makes sense. What was that, sorry? Right. So this explicitly happens after the browser has done its complete computed style. So yeah, what you just described can't happen. Yep. Yep.
Another question on the paint tool.
Yep.
What is the sort of priority of this? Does this happen after background painting, before text painting, or like can you control how it sort of interacts with the other paint stages?
Sorry, I'm just pausing. So basically, because this is a CSS image, it basically just gets interleaved with all of the other, basically the usual paint walk. Is that what you're asking?
Yeah, but at what stage?
What do you mean by what stage?
So is it background painting?
Yep. So
sort of the Z, not really Z index, but like, is it also painted by other things that the rest of the engine paints, or is it preempting that?
it's adding to what the engine is painting, if that makes sense. So if you're defining so for example, if this was background image, background image takes a list of things. So you could have an URL, a paint function, and then another URL. And basically that would just get layerized. And then that would be the background image, which will get inserted. Can talk later if you want. Okay, cool. Cool. And then final thing that we've got going on is compositing. So mainly talk to Volek for this stuff. I'm just showing the compositor worker example up on the screen here. Basically, this gives you an API hook to things that you can mutate on the compositor. The other thing that might come out of Houdini at the moment is a declarative API that represents these things. Other browser vendors are hesitant at the moment to placing script on the compositor thread at the moment. So one thing that we're looking at as well, in addition to this, is being able to define declarative APIs that cover all of the use cases. If they don't cover the use cases, then we'll still need, we still should implement the script API. So that's it of my 5-second overview for each of the APIs. Are there any more questions on the APIs? Otherwise, we'll jump to demos. Yes, one more question. So the question was, do transforms get applied in the paint function? Is that right? Right, so this is, the paint transforms aren't the same as just the traditional element transforms, if that makes, is that what you're asking?
I'm just wondering, if you get into a case where you're going to apply LCA elements or
Right. So basically, if you paint outside of the bounds of your canvas rendering context 2D, that output will just get dropped. If you want to sort of save the stuff that will explicitly be outside of the bounds, you need to define an overflow. But I'm not sure I answered your question, so yeah, let's talk later. Cool. Demos. So this is a build of Chrome that has custom properties, a little bit of the type DOM and custom paint in it, and also compositor worker. So this is the standard Google logo. This may crash. Oh wow, it didn't crash. Oh no, there it is. It always crashes. Oh God, what's going on here? As you can see, I'm hammering a raf loop there. But the important thing here is that this logo is defined with the paint function, just called logo. The main script here is basically just hammering a custom property to get to update because we don't have the full custom properties support yet. And so when I click this, it doesn't do what it's supposed to. Oh no, what's happened? Oh no, what's happened? Shane, we broke it. There we are. For some reason, DevTools affects the output of Paint. So there's a few things going on in this example. One is that we're animating the width of the element. So this paint callback is getting called back every time that we change the width. And the second thing is that when we click it, we're changing a bunch of properties to animate back to the Google logo. This is how the other native platforms at Google implement the Google logo with the bouncing dots, is they basically just issue draw commands whenever they get invalidated. And it's exactly the same for custom paint here as well. Yeah, so that's the first shiny demo. I can also show you that, love that bug, it's awesome. This is completely production ready, by the way. Ship it. Yeah. How do I increase the size of DevTools? Is it that? There we are. Sorry. Is it? There we are. There we are. I've got it. I know what I'm doing. Here you can see register paint as well. This context is just a stripped down canvas rendering context. If it will allow me to, nope, that's not going to work today. You can see here pauses inside of it. So the context is this thing called write-only canvas rendering context. It doesn't have a bunch of the APIs like adding hit regions and stuff like that. You get given the geometry, so width and height, and then all the styles that you depended on all the way down here as well. So you'll only get the custom properties, scale, and total inside of this custom paint function. Then you can see it's doing a bunch of parsing of the style elements and then drawing all of the dots or all of the Google logo as required. Yeah. This is it's a little bit buggy for some reason, but this is the polymer material design ripples on a button. So you can see that there's multiple wavefronts sort of appearing from the mouse cursor. So instead of multiple DOM elements here, we've just got one DOM element, which has a background image of ripples. And then the custom properties that we're passing in is basically what the ripples should be and what their current state are. So you could imagine that we build up all of the ripples with a web animation, just hit play, and then through additive animations, just continually add more ripples as required, and they'll just naturally drop off. Yep.
So in this case, how do you feed in the position of the mouse? Is it a custom file?
That's a custom style, yeah. So basically, it's just X, Y, this is where I want to draw the ripple. And then finally, one cheeky one that I did. You can't really see that. I don't know if this will work at this same level. Nope, doesn't work. Oh, there it goes. So just an example for mainly a CSS. Levi's entertained by my title of my blog post. Just one thing that the CSS working group is interested in at the moment is defining new things to do with borders. So here, for example, they want you to be able to define just sort of small chevrons at each of the points of the border, be able to define that just two appear, so that say the top left and bottom right just appear and things like that. But with any CSS spec, they're sort of a little bit limiting. So for example, in this border, we've got them slowly fading out on a gradient, if you can see that. This is something that isn't in the spec, but is very, very trivial to do as a border image with custom paint. So this is just like a cheeky thing that I did just to show, sort of the power. You can also see just a smooth animation there, which is happening when you scroll down just to highlight that lovely quote. Again, something that you can do with the new border spec, but this is just very, very natural and very nice to do here. I think that was all of the demos I wanted to show. Oh, I had a question? Yes, hi.
In those examples, you had a function that was in the main JS source that all the rest of the page was running in?
No.
Oh, okay, that was in a separate file.
That was in a separate file. So you can see here that this is in an unnamed worker. This was a main thread worker that I concocted up with DevTools and everything like that. So this runs completely, this is a worklet basically. It runs on the main thread, but completely separate to all of the main thread JavaScript.
And how is it invoked from the main thread?
From the main thread, just synchronously. I can show you the code later if you want,
okay.
If that would help, yeah.
Thanks.
Cool. Yeah, so this is inside worker number 10, apparently. And then it's just calling all of that. Cool, and that was just stuff about that. So that's all I had prepared. Are there any final questions?
Yeah, I have a.
Yeah.
On? Yeah, I have a question about kind of. So yeah, you have a term called worklet. So to me, it seems that it's a cheaper way of creating worker. Is that the intention? Are these cheap?
Yeah, that is the intention. So basically, the ideal situation for this spec would to be basically to have a worker per callback. We can't do that because workers for I think every JS engine are relatively expensive to do. So worklet was basically, we just have one or two of these things per thread potentially. And the other big thing is that they're synchronous and not asynchronous. So we got a lot of feedback very early on when we tried to call them workers, and then people instantly went, let's post message out to the main thread, and just not having all of those APIs. So basically the way to think about them is that they're shared execution contexts like the main thread JavaScript that are synchronous as well, so they don't have any asynchrony in them. Yeah.
When you pinch zoom, will the paint worklet get rerun with a larger canvas, for example?
I don't think so at this stage. Basically because they're just building up display lists. You don't have the notion of writing to individual pixels, so they're in CSS pixels, so it may re-raster that display list, but not actually call you back. I'm not entirely sure, because Apple have differences here, but yeah. Yeah, this is where my knowledge of Canvas starts to drop off rapidly. Cool, thank you. All right. Yep.
So what do you think the support from so are other browsers interested in implementing this, or is it just something?
A pipe dream, yeah. No, the other browser vendors are fairly interested at this point. So the Houdini task force has all the major browser vendors in there, as well as other groups like Adobe and book publishers, things like that. I think Custom Paint probably has the most support from the other browser vendors. That might be because it's also most tractable at the moment, but it's also one of the simpler to define APIs. So I don't think that will be going alone in trying to implement this. There's a lot of support for the typed OM. I think at the moment, everyone sort of sees the need that this string-based API at the moment isn't giving all the power that developers want. So I think that we'll probably see that fairly soon as well. And my hope is that with the support for the Custom Paint API, that we'll get a lot of the infrastructure pieces for the other parts. So things like registering properties and the worklets infrastructure, we'll get that, and then it'll become much easier for other browser vendors to think about custom layout and things like that. Another thing is that worklets aren't just being considered for Houdini as well, they're also being considered for all of the web audio stuff and sort of video processing stuff as well. But that's as of TPAC, so it's still very, very early stages yet for worklets.
Why is it so important to isolate the worklet's global state from each other? Like you're doing this thing where you're going to dispatch to a random worklet to avoid people storing global state, but other platforms like iOS and Android don't prevent you from modifying global variables during your paint callback. It's just a bad idea, and developers don't do it. So why are we so worried about it when other platforms aren't?
The main reason is that we're not one platform in the sense that we're just one engine implementing this spec, in that we're multiple engines implementing this spec. And so it's seen as a large compat risk, as well as just lock-in as well. Potentially if Blink, say, defines a particular paint order that the paint callbacks get called in, there will be a developer somewhere that relies on that paint order. We can't just assume that a browser with a low percentage market share is going to switch to our paint order. It's just not healthy for the web ecosystem to do that. Shane.
Is there also a cost to continually checking people are doing things that cost patches?
Yes. Yeah. So what Shane just said as well is that there's performance benefits in that we don't have to check that people check for crashes and things like that. Cool, nothing else. So thanks for coming. If you want to chat afterwards, just come grab myself or Shane as well. Other people that are working on this is Emil is looking at all of the layout stuff, as well as Levi is implementing custom properties, so have a talk to him about that. And Eddie Mead, who's just there, is implementing the typed OM stuff in Blink as well. So feel free to grab any one of us and chat about Houdini things. Thank you very much.